Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook. This one question lost more marks than any other on last year's papers. Students drew bars of the wrong height because they treated unequal class widths as if they were equal. If you've ever been sure your histogram looked right and then lost marks anyway, this episode is for you.
Section 1. The concept. First, definitions in plain English. Frequency is how many observations fall into a class. Class width is the size of the interval. For example, 10 to 20 has width 10. Frequency density is frequency divided by class width. It's the density that controls bar heights on a histogram, not the raw frequency. Let me show you why.
Worked example. Imagine exam data with 3 class intervals. 0 to 5 has frequency 4, 5 to 10 has frequency 6, and 10 to 20 has frequency 10. The widths are 5, 5, and 10 respectively. Calculate density as frequency divided by width. So for 0 to 5, 4 divided by 5 is 0.8. For 5 to 10, 6 divided by 5 is 1.2. For 10 to 20, 10 divided by 10 is 1.0. Notice how the middle class has the tallest bar, even though its raw frequency is only slightly higher than the first. That's because its density is higher.
Why this matters? If you drew bars proportional to frequency, the 10 to 20 bar would look taller and you'd be wrong. Examiners expect density on the vertical axis, so every bar height reflects frequency per unit width. Write it down on the script. Frequency density equals frequency divided by class width. That's your key formula. Practical drawing notes. Choose a sensible scale for the vertical axis that fits your largest density. Label the vertical axis frequency density and include the units, for example, students per unit, or the actual measurement used in the question. On the horizontal axis, make sure the bar widths are to scale. If one interval is twice as wide, the bar must be twice the width. Draw bars touching each other because data are continuous.
Section 2. The exam technique. Here's where the marks are. For a typical 4-mark histogram question, you can expect M1 for calculating frequency densities correctly, M1 for choosing and labeling a correct scale on the vertical axis, M1 for drawing bar heights in the correct positions with correct widths, and A1 for a completely correct histogram with labeled axes and units. Let's break that down so you know exactly what to write.
What examiners mark? They look for evidence of method. Show your calculations for density next to each interval. That gets M1, even if your final bars are slightly off. Label the vertical axis and write the units. That's another M1. Draw the bars to the heights matching your densities and ensure widths are accurate. Third M1. The final A1 is only awarded if everything is consistent and labelled.
Common examiner traps that cost marks. Using raw frequency instead of density, drawing bars with equal widths when they aren't, forgetting units on the vertical axis, leaving gaps between bars, or not showing your density calculations. If you make one of those errors, you might lose 2 or 3 marks, even though the data looked close.
Curious. Section 3. The quick win. I want to give you a 10-second checklist you can use every time. Say it in your head before you draw. 1. Calculate density for every class as frequency divided by width. 2. Sketch the horizontal axis with widths to scale. 3. Choose and label a vertical scale that fits the largest density. 4. Label the vertical axis with units. 5. Write your density calculations next to the intervals. Do this every time and you'll stop losing avoidable marks.
2-minute practice. Try this mini question now. Intervals 0 to 2, frequency 3, 2 to 6, frequency 8, 6 to 10, frequency 4. Widths are 2, 4 and 4. Densities 3 divided by 2 equals 1.5, 8 divided by 4 equals 2.0, 4 divided by 4 equals 1.0. Sketch widths to scale across the horizontal axis. Mark the vertical axis up to at least 2.0. Label the axis frequency density and write the units. Drawing that will take you under 2 minutes and gives full marks if neat and labelled.
Worked example and common pitfalls. Annotate to claim marks. When you answer an exam question, put your density calculations down as separate lines. 0.5, 4 divided by 5 equals 0.8, and so on. Circle your chosen vertical scale and write the units beside it. If you have a slipped bar, the examiner can still award method marks because your working shows you understood density. Write it down, don't just think it.
Common slips to avoid. Omitting the units on the vertical axis. That's an easy lost mark. Drawing bars with equal widths when your intervals differ. That's often fatal. And drawing bars with gaps as if it's a bar chart for categories. Histograms must touch. Finally, always read the question twice. Check whether the class boundaries are given as inclusive or exclusive, and check the units. Read the question twice, solve it once.
That's your quick win for today. If you want a printable checklist and fully worked solutions for this episode's examples, visit the link in the show notes. Practice this checklist on every histogram question and you'll see steady improvement. Stay curious.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.